All right, so just reminders kind of where we stand on grading things. I'm still grading math packets. I'm on to the last page of all of them. I'll probably have them back next class. So far, so good. In general, just remember that when I'm asking for proof, I typically want more words and not just algebra. So it kind of differs, but that's just my general comment so far as I'm going through it. The chapter 2 algorithm analysis packet is either now with you or up here, or I didn't get it. So make sure that you hand that in as soon as possible if you got a 0. A note for this one that I'm handing back. So for the packet, it's fine if you just wrote like O of whatever, theta of whatever. But for the homework or exam, especially the homework that's due on Thursday, I want to know what's for each of the big O or big omega, what's C, what's your G of N, and what's your N naught. So I want to have each of those things written down for every big O and big omega. So homework 3 is due on Thursday. The plan for today, we're gonna keep going through the packet. We stopped in tic-tac-toe, so we'll briefly review what we talked about and then talk about it as a class and then keep working on it. Yeah, we'll see how far we get. I estimate either this is the last class or next one will be the last class for data structures because I want to get us moving. The other thing this is mostly just like my housekeeping note. I'm debating about whether I want us to actually cover sorting or whether I just want to move us along into divide and conquer. So I'll let you know next class where we stand on that. And then we'll have the last however many minutes to meet with your group if your group's here. Okay. Let me open the right file. Data structures in class. Okay, so last time we were working on the packet, one of them is design a stack that has our usual suspects, but also the ability to find the minimum, that all of them operate in constant time. We also talked about how do we maintain our refrigerator so that food spoilage doesn't happen. What data structure are we using for that? And then we stopped with tic-tac-toe, where we've got tic-tac-toe on an n by n grid. And the question is, how do we create this order n data structure that accepts some sequence of moves and then reports in constant time whether the last move won the game? So we have a solution here. So I want you to talk with your neighbors and kind of review what were you thinking of. Does the solution we talked about last time help you help push along the solution that you may have thought of? So I'll give you maybe 3 minutes or so to just talk about it amongst yourselves, and then we'll come back and see, do we have other solutions? Okay, so we'll come back at 45. That's good. Yeah, it's on Canvas. Should be. Um, where's that? Oh, it is on Canvas. Yeah. Okay, what's your question?
So what if say we have like an 8x8 row
Mhm.
or matrix, and I say like is the rules like full row and column diagonal needs to be 8, like or is it like 3 anywhere?
Like, are you thinking, could we have,
I just wanted to specify or more. I don't know, say
like, could we have like like a rectangle?
yeah,
Is that the question?
or no, kind of like it just does there need to be just like 3 X's anywhere on the 8x8, or does that have to be 8? Like
It would have to be 8. Yeah,
that's fine.
yeah, it has to take up the whole row or the whole column or the whole diagonal. Okay, 2 more minutes. Sorry.
Or is it?
Oh, if it's missing, yeah.
Okay, I was wondering.
You can turn it in on paper. So the thing is, and the beginning assignment, such a file upload. It's a double file. That's
Oh,
it. That's
okay.
the date on it.
Okay.
Once I grade it, if I really don't have it, then I'll label it. All right. So let's come back and talk about tic-tac-toe. So we have a candidate of where previously we have a candidate where we've got an array for the number of rows and the number of columns. And those represent, like, in this column and in this row, we have some value, and the value is associated with +1 if it's an X, -1 if it's an O. And then we have another array for one diagonal and the other diagonal. So last time we went through a game and found that this does probably work. But that's one candidate. What else did you come up with? Anybody want to share what their group talked about? Even if it's wrong. Go for it.
Up with setting up an account for every win, I think. Like for every column, every row, like that. And then when someone plays an X or an O, it adds one count to their count for those win scenarios that they're playing involved in.
So do you have, it's like X player and O player?
Yeah. So if the X player puts in their coordinates for where they can,
Mm-hmm.
that goes through the program, selects the win cases for it, and then adds one to the count. Then once the count reaches 10, for whatever size.
Mhm. Okay. So that's, and so that's kind of like what we have up here, except instead of like the global keeping track where we've got +1 for X, -1 for O, it's duplicated. And so each player will +1 as they proceed. Okay. So I like the sound of that. Is it order n? Mm-hmm. So we've got, so the rows would be n, the columns would be n. The diagonals is, I think we talked last time where there's like exactly 2 diagonals. And so if for X we've got 2n + 2 and O we've got also 2n + 2, that's 4n + 4, which simplifies to n. So I think I buy that. Is it 2n or n squared? I think it's 2n, but I'd like to hear reasons. Ideas? Yeah. Yeah, so this is where, like, having it be order n space is, because we're working with an n by n grid, and we have n by n grid, then there's n squared spaces. And so keeping track of the difference, whether we're working with n squared or whether we're working with a multiple of n, is really important. So I would say, since this is only like, there's gonna be n rows and n columns, and we're only representing like one number for each of those n's, I would say that this solution would be order n. But if you're representing the actual matrix with those n squared spots, then that's where it's not order n. Okay. Awesome, thank you. Anybody else want to share what they thought of? Anybody come up with something that like really isn't gonna work? Okay. So thank you for playing the tic-tac-toe game. I actually really like this problem because it's very difficult. And so that's kind of what I want this time to be, of just, we have a difficult problem and let's try and solve it. Okay, so let's move on to the next one, which is design a data structure to support the following operations. Where we're working with sets, and we've got inserts, which is inserting the item to the set. Remember, order doesn't matter in sets. Delete is to delete the kth smallest element. And then member returns true if and only if the value that we give is in the set. And with the caveat that all of these operations should take log n time on an n element set. All right, think about it. Go. All right, what are we thinking? Here, let me walk around and see.
That's all. Yeah,
But it was, we just were the same way that you. Just really. It's like when you teach you.
Names, like, providers are things that make you want to adjustments.
Yeah. So this is, yeah.
Yeah. What do you think of the thing? Depending on how far down you want to go.
That might be-
All right, so for the most part, I've seen that we want to use a binary search tree. At least one person wanted to use a priority queue, and other people wanted to use an array. And so it depends, right, on how you are, like, the way that you approach the problem can affect how it gets framed in your mind. I will mention, so I think binary search tree sounds reasonable. One thing I mentioned over here is the drawbacks, one of the drawbacks of arrays is that, so if you've got fixed points in memory, one of the things, if you're inserting into an array, then you have to like shift all of the things after that over, like you shift everything over by one. So it also depends on how you choose to implement the data structure, because like binary search tree could be implemented using an array. And so then insert may not be, depending on where you insert, may not be constant time. So there are assumptions that you can make that affect the efficiency of the data structure that you choose. This is what I'm trying to impart, is that like everything's kind of all linked together. So like if you know arrays and you know linked lists, then you can pretty much build everything else. And everything else kind of boils down to some of these basic data structures. Okay, so let's look at the binary search tree. How is insert log n? Someone want to say, just like give me a summary? Sure.
It's how the finance search tree is structured, because you don't have to go through like each element.
Mhm.
You just have to check if it's greater or smaller than the current one.
Mhm.
It is the right, it isn't right, it's what. And it's reached like the loop node, I think affects everything that's, you know, that.
That's where it goes. Yeah. Yeah, that's the main idea, because so binary search is log n because log base 2 of n, because we throw away half of the list that is not applicable. And so that's how we, yeah. So I buy that. Delete. Anybody have a delete mechanism for binary search tree that runs login? Yeah. Yeah, so we go all the way to the left and like that's the smallest one. Yeah, this is tricky of how do we delete the kth smallest element. So one I think is easy. N is also probably easy because we just go the other way down to the right. Yeah, okay. What about C? This is also just like binary search. This is just traversing, like looking for the key in the binary search tree. So I think this one's easy. I think delete tends to be the hardest one. Okay. Any other comments on this one? Questions? All right, let's move on. So what method would you use to look up a word in a dictionary? Like, I think we're assuming like the actual like book dictionary and not like the data structure dictionary. Okay, talk about it in your groups and then jot something down.
Yeah. All right, so let's say I'm trying to look up establish in my dictionary. What do I do?
do you do to look up establish?
It looks like near the start of where the diction, like where A, B, C, or E is.
Mm-hmm.
Stuff like that.
Okay, so that process seems to be like order and like
Yeah.
and maybe to start from A and go B, C, D, E. And then once you're at E, what do you do?
Up there, I guess you could, I guess whatever word you're at, check it's B, then it goes from E, and then after that, the next letter is in alphabetical order as well.
Mhm.
For some your S.
Mm-hmm.
Like, small weird. Yes.
Yeah, and
And then
so on.
eventually-
Okay. Anybody else have?
But whatever, yeah, estimate where I think it might.
Mhm.
Wrong, flip another chunk, correct direction.
So that's, yeah, so that's kind of more like the binary search method, like, maybe you don't start halfway. Maybe because if this is our dictionary, maybe we start like over here. And then you adjust as needed. So maybe like a modified binary. Any other methods? Let's see if we can get a word later on in the alphabet. Soup? How do you look up soup in the dictionary? Yeah, so I like this question mostly because like there's a difference kind of between how we can design algorithms of like this is how you should search something efficiently versus when you're actually provided with something to search of how do you figure out where it goes. And so like I've got a searching problem when I'm alphabetizing all of your packets where if I was doing it really efficiently, maybe I pick the middle and then now I know, oh, here's where this name goes before or after. But maybe in reality, I like kind of know where like all the J's are and then I can adjust based on that. Okay. So if we've got a closet full of shirts, how do you organize them for easy retrieval? What do you base, like, do you have some sort of category or order that's enforced on your shirts? Talk about it in your groups. All right. What's your ideas? How do we organize our closet?
By color, by or palette, shirt.
Is that how you spell palette? Yeah, let's just go with it. Let's just go with it.
One, yeah.
I was gonna say only 1, 2. Okay, whatever.
Palette. Okay. Thinking of like Pallet Town in Pokemon, but that's not how it's spelled. Okay, so sorting by color or palette. And then how do you retrieve them?
I guess, in case I'm working backwards, I have like a pair of pants,
Mhm.
so then I would go according to that section. I wouldn't even look at the other section.
Okay. All right, sounds good. Other organizations? Length of sleep. Okay, and then how do you select? Yeah. Yeah. Okay, other ideas?
So, right, then color. And then I would select to wear, depends on the weather. If it's sunny out, I'll wear my color.
Okay, so. Type meaning. Okay. Okay. Other organization methods? I know I heard some discussion of like casual or
Yeah, you know, casual.
yeah, so then you can like decide this is, yeah. Yeah. Anything else? Okay, so I hope this teaches you that as you're trying to enforce some sort of order on data sets, sometimes the order that you can see it on a data set is going to be different than the order that someone else sees on the data set. Or maybe it's like a combination of all of them. All right, number 7. So web crawlers being like bots that go and look through websites and maybe categorize and organize. Um, um, need some sort of way to figure out what have you visited. And once it is visited, then we need to make sure to not visit it again. We want to find a data structure for maintaining those. I have like a tangent on this. On pretty much any website, you can go to, like, let's go to St. Mary's ca.edu. For pretty much any website, there's a hidden page, robots.txt, which basically says, here's where I'm gonna allow robots to visit. This is useful for like search engine indexing, and stuff like that. So if you have a favorite website and you want to see, does it have a robots.txt? Let's try this one. Cool. So I think this lets, like, user agent is like, here's the pages where I'm gonna allow you, and then disallow is, in this case, none. Anyway, that's a fun aside. But the problem is we've got a web crawler. How can we keep track of where we visited? And for this one, we don't have any restrictions for what it needs to be. But once you come up with something, just think, can you do better?
Yes.
Here's the first level. So into one, another to the whole. Web salaries also down.
It's not even, yeah, I think that would be really good, Kelsey. Yeah. So, I should, yeah, I should be sure, partnering with you to, instead of having a community team, it's also but yeah, for this, I'm trying between a dictionary, well, a dictionary, but we have to have buckets, you have to have big buckets. So,
Yeah.
Yeah, and that's like the big after. But also, I think that's should be
That is the like.
Say Mary Tom.
Same, same. That many, 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 many.
Same,
So maybe it doesn't make sense to have. Right. All of Where is it going? How I can convince. Yeah, so like.
For eight, for seven, it's for seven. Dictionaries. Well, what was it? You would do there's no way to fully automate. Why is it all?
And so words trying to say yes or no.
That's fair.
It's like, it's
I mean, like realistically, you have to really try.
like.
Kudos. Traverse it. But then you can. Huh? You should go ahead and try with that.
Yeah, we had
All right. So I think most of us kind of have the same answer. For the web crawler, which tends to be hashing. So let's talk about how you're hashing and what it kind of looks like. So can I get a volunteer who's not John? Because I want to talk about yours after I hear someone else's. Go for it.
So you just basically use the, well, just have a very large allocation of just like storage and then. And then you can just use the URL, you can just turn that to your, with the ASCII values. Use that as a key, and then within each hash, you just store whether it's readers or not. You can just use whatever is like the hottest hash algorithm you want.
All right. Okay, so having this big array and hashing the URL somehow into an integer and then storing to an array. I know this group over here was kind of talking about some issues that may come up with that. Do you want to discuss?
Yeah, well. Talked about like, yeah, if you had some hash functions and add collisions. And you're talking about, on check was like, just check if, you know, the array is empty at this like given hash value. And if it's empty, then like no one's busy with it, but we're saying like, well, if there's collisions, then something might get probed to like, next open spot. And so like, even if you check, like you're doing hash value and, it's not empty, it could be like something, like another website plugged into that. And so that even though no one's actually visited your site, the hash function is not empty. But, that's just checking, whether it's empty or not, also assuming the hash function gives us collisions and stuff like. So, really complicated.
Mm-hmm. Yeah, thank you. Any other thoughts? How might we resolve collisions? Or different ways that you structured your hash table? You want to go now?
I gotta think they hash the URL and then store that hash into a binary search. So, like, the time for search will be login. That's basically the and
Mm-hmm. And then that can, so this is the idea where hash gives you some like unique key. Um, I'm blanking on the hash like SHA something. Like there's hash functions that will take some text and produce some other unique text. With like really good hashing algorithms that are unlikely to cause collisions. And then if we've got some alphanumeric string, then if we store it in either a binary search tree or maybe a sorted array, then we can have this log n search to just check, is it there? Yeah. Any other ideas? Yeah, so the idea for this one is, so like everyone pretty much got hashing, and then the only question is, can you find problems with what you've come up with? And how would you want to fix that? So one of the things here is like, how do you hash it? And so maybe you choose a really good hashing algorithm so that you're sure that collisions won't happen. That's an option. Okay. Last problem, I think we'll go until maybe I'll try and discuss it at like 57 or so. So I'll give you a few minutes to work on it, and then hopefully I'll have like 10 minutes or so for you to talk with your group. All right, so this one is give an algorithm, pseudocode's fine, for finding pseudocode or just like stating here's how you do it. For finding an ordered word pair occurring with the greatest frequency in a given web page. So like what's the word pair that happens the most? What data structures, if any, do you want to use to keep track of that? And then again, optimize for both time and space. All right, go for it.
That's one thing, but I don't do that. But that's-
Sorry.
I think if you know the word here, then that's easy.
Yeah.
If you want to find the you have to trigger several times. The beat of that is usually around
How could you do that?
I kind of forgot how to see it.
Okay, I can put this as well.
Because if you're thinking the hash table, use a hash table, you can have constant hash table searching. If you wanted to search for the greatest analysis, you lose the benefits of that because you have to use that. Until you find search. Oh, yeah, that's what I thought.
That's what this is. I'm guessing you using it as a form of. You're the guy.
All the things of like your. I'm not talking about the last one. Uncle House. Yeah, no, really.
Yeah.
Oh, also.
I would say probably 2 years.
What do you guys?
Or even if it's like.
No, you said it.
Okay, we've got a lot of great different ideas. We've got a max heap, we've got a binary search tree, priority queue, and dictionary. I think to me, dictionary would be the one that feels like the most intuitive sense. If you go through and get pairs, those are the keys. And then the value is how, like, how many times this appears as you go through. And that would just maybe require just go through the whole page once. And then with your dictionary, you just go and find what's the maximum. So yeah, I think that makes the most intuitive sense. But again, so we haven't really talked about what a heap is. If we skip sorting, this is a good reminder that I need to cover what a heap is. But yeah, and there's other ways of, like, maybe we represent it in some other fashion. Does someone who is thinking priority queue want to briefly explain how they were thinking of storing the data? Okay. Mm-hmm. Yeah, so instead of, for a dictionary, since we're keeping track of all of the pairs, and then, yeah, I think that it's a good spin on the problem. Someone who was thinking binary search tree? If you have a comment. Okay. Do you want to say something about max heap? No?
Well, I was thinking that, yeah, because, Dictionary, you get constant, time with search and hashing.
Mhm.
But if you were to iterate through the entire dictionary, you would lose the benefits because that would be lower than average. You
Mhm.
have to iterate through each one to see the maximum. But what Kelvin was saying is you can store it in a separate variable called, current max. And then every time you add, just update that.
Yeah.
Which is just like a tuple of the word pair. To count, yeah.
And so like maybe you add that as a function, like, yeah, to dictionary. This is the thing, like we have the basic formulations of these, we can edit it and amend it as we see fit. And that's the thing that we were doing all the way back in that first problem of like, how do we maintain the minimum value in our stack? We can do that. We just have to think it through of how do we preserve the functionality that we already have to allow us to do this additional thing. So the data structures that have been taught to you, those are like the bare bones. And then when you have some problem that you want to solve, you can amend those and work it out and see what you need to change. All right, so thank you. I think we should be roughly done with this packet. So I will collect it today. And if you don't have it now, or if it's not fully filled out, that's fine. If you want to take it home and scribble on the one that you've got at home, or take pictures, turn it into Canvas, that's up to you. And then the rest of the time, I will have you meet with your groups and just turn in the packet when you leave.